Hey everybody, and welcome back to another fun and exciting intermediate math class. In today's lesson, we're going to be in lesson 8.6 in your book, talking about line graphs, and that is on page 332. And what we'll be talking about today is kind of how to draw line graphs, how to read line graphs, kind of what they are, that kind of thing. So go ahead and look down there in the book, look down here at the screen, and let's define what a line graph is. Line graphs are used to record and plot numerical data to show how it's changed over time. So, for example, maybe we're talking about the sales of something, how much something is selling. So in June, we had 50 sales. In July, we had 60 sales. Okay, so we would put that information on a line graph so that we could see what's happening. Are we going up or are we going down? That's kind of the idea of what a line graph is. Pretty simple, pretty basic, but it's useful information, especially for somebody looking at something like population, finances, anything that really has numbers that change over time. This is very useful to use. So let's talk about the steps to construct a line graph. If you're asked to draw a line graph, how would you do that? The first thing that we want to do is we want to decide on an appropriate scale. Let me kind of scroll down here and show you something real quick. So if we're talking about something like a line graph, what we want to do is we kind of start. I didn't really talk about this, but you want to start with the basic box, if you will. And then you want to do a scale. In other words, like every so often, we're going to put a line across. Okay, I'm not doing really beautiful lines right now. I'm trying, but I'm not being very successful. And then you want to make this some sort of a scale, if you will. Like how high we go on this graph means something. How far left and right we go on this graph means something. So every line on your graph is going to mean something. So here's the idea. If we have, let's say that we have our data was 60 and 100. You don't want to come over here to your graph and say, okay, this is going to be 0. This first line right here is going to be 50. This line right here is going to be 100. This line right here is going to be 150. You get the idea, right? Okay, this line right here is going to be 200, and then, 250. Well, if my data point is 50 and 60, then that means that let's say all my data points are like 50 and 60. So 50 and 60 and 50 and 40 and 60. See, our line is going to be down here. Well, we're not using the whole graph, right? That doesn't make sense to have a line that's just real small. Or even more so, what if we did, this graph being something like 1,000 and 2,000 and 3,000? You get the idea? Well, now these points that we're putting on the graph are going to be like, they're barely going to be registering on the graph. So, our first point's 50, it's going to be like down here, and then 60, and then 40, and then 50, and it's not even really moving on the graph at all. So, our line is it doesn't make any sense. Okay, so this is important. The scale is important to your overall graph, because if you get it right, your graph will look right. If you get it wrong, your graph's going to look wrong. So the first thing that you want to do is decide on an appropriate scale. Very important. The next thing you want to do is you want to title your graph, just like every other graph that we've titled. Come up with a name, make it, something that reflects the data that's being shown. What we would do for the one that we were just talking about is something like car sales during the summer, or car sales during 2023, or whatever. You come up with the way that you're going to title your graph there. All right, next we want to label the graph. Okay, so the up and the down, right, that we were doing those on a vertical up and down scale. So let's go back down here to this right here. So this would be our vertical up and down scale. And this would be, we need to label that as well. We need to say what that is. And this over here might be like sales. Okay. How many sales did we have? That's on the vertical. That's going up and down. Typically on a line graph, on this going this way, left and right, is going to be your time. So like this first point was June, and then July, JJ, and then August, and then September, and then October, right? Jason, no, then October, then November. Jason, oh my goodness. So that's one of my best friend's names. So there you go. July, August, September, October, November spells Jason. Did you know that? All right, now you do. All right, next is plot the points. Now we're going to actually take, once we get everything done, we're going to actually put the points on the graph. Then next we're going to connect the points with the line. That's where our line comes in, right? It's a line graph. So we connect the points with a line. Now that line can look different. So there's a couple different ways that that line can look. Types of lines on a line graph. The first one is a broken line graph. Broken line graphs are like they go up and down randomly, okay, like mountains. Okay. The next one is a curved line, and so it's just going to do a simple curve. It can curve up, it can curve down, it can curve in whatever direction. And then the third one would just be a straight line. So there's three different ways that you can have a graph, a line graph: broken, curved, and straight. Typically, line graphs are broken unless they show some sort of consistent data. Consistent data like maybe population growth or the growth of a virus. There's a lot of things in science and in real life that kind of stick to a curve or even to a straight line. But then usually in finance, in business, things like that, you're going to have a broken line graph. So it just kind of depends what you're using there. After you can't know that really until you get your points on and then draw your line. Then you're like, okay, it's broken or it's curved or it's straight. All right, next let's take a look at a couple of examples. These examples are in your book, page number 332. We can go through this one. So what is going on here? Let's just take a look at it. What's the title of the graph? Taylor's Toy Shop Sales, 2017. So I'm making this video in 2023, so this is just a little bit outdated. You're probably watching this video who knows when, so maybe I'm outdated. So, but anyways, I'm already outdated, yes I know. But anyways, so that's our title. Look, we have a line. What kind of line do we have? We have a broken line, right? Looks like mountains. It kind of curves just a little bit right here, but it would still be broken because of this beginning here, and then we do kind of have a little bit of curve at the end, but this is considered a broken line. All right, over here we have our sales in dollars, so we go from 5,000 to 10,000 to 15,000. See, this wouldn't make sense if our scale was 50, 60, 70, 80, would it? No, by tens, because we'd have to draw a line graph that was huge in order to get to our numbers. So this makes sense going by $5,000 increments. Over here on our horizontal, we're going January, February, March, April. So we're going all 12 months of 2017. And we're showing the data points. So it looks like in January, we sold what? In February, we sold what? Well, how do you do that? You go up, take the month, and then you go over and you see where it's at. So it looks like somewhere between 10 and 15,000 in February. We sold about maybe 14,000. Now, line graphs are not created to give specific information. They're just not. Line graphs are created to show kind of the flow of information, kind of how it changes over time. You're not looking for specifics when you look at a line graph. You're not looking exactly how many toys did Taylor's shop sell in June. That's not what we want. Okay, we would have to pick a different type of a graph or different way of demonstrating the data. This gives you about close to the number, but it doesn't give you exactly the number of toys that were sold. Right, so there's some questions in your book. It says, what month had the highest sales? Well, let's take a look. Looks like July's pretty high. It's the highest. Oh, December, look at that. Oh, I wonder what happened in December, right? Who buys toys in December, right? Yeah, parents buying Christmas presents for their kids. So, boom, way up there. And so December is very high. So December would be the winner there for the highest sales. B, between what 2 months was the greatest drop in sales? So we're looking at the biggest decrease, where it went from a high number to a very low number. So looks like there was some decrease here from March to April, and you could write these out. You could write these numbers out if you need to, or I think you can probably see this visually. There's a little bit of drop here between August and September. All the other months look like they're raising, they're going up. So, and then this one right here, look, from July to August, that's a big slide right there, okay? So we went from way up here to from 34,000 all the way down here to about 17,000. So pretty big slide right there. So that would be the winner there, would be from July to August. How many times did the sales increase between months? All right, let me grab my pointer here. From January to February, it goes up. Look, there's an increase. So that's 1. From February to March, it goes up. That's 2. And then we have a decrease. And then from April to May, it goes up. That's 3. May to June, it goes up. 4. June, July, it goes up. 5. Then we go down. Then we go down. Now we're in September to October, it goes up. So there's 6. October, November, there's 7. And then November to December, that's 8. So we're going to have 8 increases. So how many decreases would we have? Well, there's 12 months. So we're going to have 1 decrease, 2 decreases, 3 decreases. And you say, that's only 11. Well, but one of them was a starting month. So we didn't have an increase or a decrease in the starting month. So there's only going to be 11 values there of going up or down based on 12 months. All right, next, letter D. What is the value of the first minor grid line? Well, we didn't really talk about minor and major grid lines, but let's kind of talk about that. So major grid lines are going to be these darker ones that are at these numbers. So that's going to be a major grid line right there, okay? It's at the number. 5,000 is a major grid line. 10,000 is a major grid line. 15,000 is a major grid line. You can see this a little bit better in your book than you can on the screen. So if you want to look in your book, that'll be good. Now, in between that, you have this little smaller, thinner line. Okay. So what does this line equal? Well, this line equals 2,500, right? And so this line would be 5,000. Then this line, the smaller line, would be 7,500. Then 10,000. But now look, this data point right here is not on either line. So that can be a little bit confusing, right? Well, that's where you kind of have to do a little bit of guessing right there to try to get figured out how much each point is worth, if you will, because some of them are between lines. And that's okay. Again, we're not worried about the overall data. All right, letter E. What was the amount of sales for February for September? So basically, they just want you to look. February looks like it was real close to 15. Maybe we'll go with 14,000. And then September. So September was a little bit over that. Looks like we were close to about 16,000, 16,500. Again, this is estimates. You're gonna put just kind of a round number right there. You're not gonna put an exact number. Well, that's all I have for you in this lesson. Line graphs, not too bad, right? So just take the time there, follow along with those steps for creating a line graph. And if you have any questions, slide it back, watch it again. That's all I've got for you. Have a good one. Bye-bye.